But I want to talk about the general form of first order. So the general form of a first order. General form of a first order is very clear and very interesting, and that is just dy dt equals to f of t and y. So this is the general form. Please don't be confused. You can also use dy dx x and y. So don't get yourself confused. It's all about variables, all about understanding. So t here, this is a general first order differential equation. Is always having this form. This t here can represent the independent variable, and y there is your known function which we are looking for. And just the same thing here, x here is independent variable and y is the unknown function we want to get. And to solve this kind of equation, we must check if it is separable. So we must check if it's separable. By separable, we check if this particular function is separable. It can become a product of the function of t and the function of y. That is, we check if this dy dt can be written as f, let me call it f1, okay, let me use something different letter, maybe g of t and h of y. So what we're trying to do, we're trying to see if we can separate these two functions, like split them into a function of at and a function of what? Y. If so, we say that the function is separable, and it is easy for we to have dy and h of y if it is different from 0. Take note that h of y is different from 0, and we can differentiate this or integrate this, and this will be equals to g of t dt, and we can also integrate this and leave in a constant of integration. So if we always discover that we can separate this, we can do this to solve our problem, and we go our way. But this is not always very easy. Sometimes you cannot actually separate this equation, and you have to bring in a substitution for if this is separable. For instance, if this is not separable, you have to put u probably equals to vx, something of this nature. U equals to vx, and have du dx to be equals to v plus v plus x dv dx. So take note, I want to make this statement. Now, whenever this is separable, we can do this to solve. But whenever it is not separable, you can check for homogeneity. You can check for homogeneity as check if f of t x ty can be equals to t raised to the power of n f of xy. So you can check this. I'm going to do that in the part 2 of this video. Sorry, the part 4 of this video. I'm going to do that. So you can check this, then you now apply this and solve the problem. So let us solve a problem on this equation. Okay, so we are going to solve this particular question. We're going to solve this question using this notion that we can separate the equations. So we have a question here, and we really don't have any job to do here. We don't have any job to do. This is quite simple because this is already separable. It's obvious. This is a function of y, and this is a function of x. So it's separable already. You can see that you have y prime equals to, this is our h of y. This is our h of y, while this is our g of x. I'm sorry, using y and x this time. So it's easy to separate this form. So we can use this formula and have integral of dy divided by our h of y, which is e raised to the power of minus y, equals to integral of g of t, which is g of x in this case, and that is 2x minus 4 dt or dx in this case plus our arbitrary constant. So this will give us e raised to the power of y dy equals to our integral of this. I hope you can remember integration. Always visit my integration video on my YouTube page. But this, to integrate this is going to be 2x raised to the power of 2 over 2. That is to integrate this. And to integrate this, you are going to have minus 4x. So to integrate this, you are going to have minus 4x. And you have your c here. Integral of e raised to the power of y is t e raised to the power of y, exponential function. So this is going to be e raised to the power of y equals to x squared minus 4x plus c. You can also write the function as y equals to the natural log of x squared minus 4x plus c. So this is more like the very answer, very simple. So this is quite simple. I'm going to bring a question in the next part, which is the last part of first order differential equations, a part that is not separable, but we can check for homogeneity and we can solve in a simpler way. So if we can't separate this, what do we do? Like I said earlier on, you can make use of this substitution. You can make use of, so this is not separable. So this is not separable. You can always give it a try, see if you can separate this. So this is not separable. We can't separate this equation. Since we can't separate it, we are going to have two. We are going to put u to be equals to vx. So this v more like sorry, we are going to put y. I think it's better we say y. Sorry, better we say y. I think it's better. Better we say y. Is that okay? Yeah. Better we say y than u. So we say y, put y as vx. So that means that our dy dx is going to be v plus x dv dx. So this is a big deal. So here we are going to have 2x, y is now vx, dy dx is now v plus x dv dx equals to 3vx all squared minus x squared. That is going to give us v plus x dv dx, and this is going to give us, if we factor this out, this is going to give us 3v squared x squared minus x squared divided by 2x squared v. So I divide both sides by this. This is 2x squared v, and I have that. So you see x squared is common, so we can cancel them out and have 3v squared minus 1 over 2v. If you cancel out the x squared, we have that at the end of the day. We can subtract v from both sides here. So we subtract v from both sides, and that will give us 2v. Here we have 3v squared minus 1, and here we have 2v squared. So I believe you understand the elementary algebra. That's something you can always pause and look at that closely. Okay, so what do we do after that? That will give us v squared, that should be v squared, minus 1 divided by 2v. Here we have x dv dx. So boom, here we have an equation that is separable. You can now see that this is a function of v, and we also have a function of x. So we go back to this and we'll round it up. So we're going to use this system to end that equation. But take note that something is different, and what is different is that our integrating factor, please recall that y is equal to v of x. I'm sorry, did I use the word integrating factor? I actually meant, in this case, we can rewrite this as 2v, v squared minus 1, and this is dv will be equals to dx over x. So I'm going to integrate this and integrate this plus the natural log of c. I'm going to explain all that why we have the natural log of c. So because when we, I actually made you have v squared here, which is now the denominator here. So you have 2v, which is now the numerator here. dv is still here. dx is now the numerator here, and x the denominator here. More like multiplying both sides and of the equation. So this is going to give us this, which we integrate both sides. Now this is obviously going to be lean. If we integrate this, please, I'm not going to go into how to integrate it. I've actually done a video on integration by substitution. Integration of this is going to be ln of v squared minus 1. So if we integrate this, we have ln of v squared minus 1, and if we integrate this, we have ln x and we have ln c. Why I actually brought this as ln c from the beginning is so that we can unify this. So that is the aim. Some author will leave this, so take note. Some author will leave this way and write this at the end of the day. It's okay. Anyhow you understand it, it's okay. But I think this is preferable. So this will give us ln of v squared minus 1 equals to ln of xc, and you can see that is the same thing as having v squared minus 1 equals to xc. And remember that this is v squared equals to xc plus 1, and you remember v was actually y over x. Y over x squared is equals to xc plus 1, and we have our final answer to be y equals to y squared, or you can say y equals to x cubed c plus x squared. We have a square root of that. So this is actually the general solution to this equation. This is the general solution to this equation. Please, you can find out how I simplify this. This is just elementary mathematics, and most of you guys can simplify this for we to have that at the end of the day. So thank you very much. This is first order differential equation part 1, 2, 3, and 4. I'm going to be coming later on with the second order differential equation. Remember to share the video. Remember to also like the video, and we also welcome your sponsorship.